Hi, algebra students. We're continuing our work with functions today. So I'm going to share my screen with you, hopefully, so you can see this presentation. Try it again. And the first slide has the warm-up. So go ahead and grab a piece of paper, stop the video, and give this a try. Okay, welcome back. In the warm-up, you are asked to state the domain and range of the given relation and to tell whether or not the relation is a function. So if you remember from last class, we talked about the domain was the x values of a relation. So I'm going to write down over here domain. Hopefully I'll write domain. And our domain are the x values. So I'm going to make a brace here, and it looks like we have -2, 0, 1, and 3 in our domain. Okay. Our range then is the y values of a relation. So if I look for y's, I have -3, 1, 3, and 4. Okay, next it asks us to tell whether or not the relation is a function. So I'm going to switch color here. So remember, we're looking for any repeats of x values, or if we were graphing these, we'd use the vertical line test. So I'm going to change this mapping diagram to be a set of ordered pairs, because remember, all relations can be written as a set of ordered pairs. So in this first point, I have -2 for x, and it looks like it's matched with 1. And then I have -2 again, and it's paired with 3. And then I have 0 for x, and it's paired with -3. 1 is paired with 4, and the x value of 3 is paired with the y value of 1. So again, we said we're looking for any repeat x values. So right away, we can see that we have -2 paired with 1 and -2 paired with 3. So since the x's repeat, we have each value of the domain is paired with 2 different y values. So this is not a function. If you were to graph those points, you would see that you could draw a vertical line that passes through both -2, 1 and -2, 3. All right, you have several vocabulary terms to copy down in your journal today, so please pause the video and go ahead and write those down. All right, hopefully you got those. Let's look. I think there's some more vocabulary in the next slide. All right, welcome back. Hopefully you got those all written down in your journal. So it says to try problems 1 to 4 on your own in your journal. So let's take a look at those problems 1 to 4 in your journal. And these are on page 68. Okay, so first of all, it says determine whether the graph is linear or nonlinear. So on number 1, I'm just going to draw it down here. The graph looks like this. Okay, we have this line curving up like that. And as soon as you can see that it's curved, you can say that it's nonlinear. So in order to be linear, it literally is just that. It has to form a line. So number 1 is nonlinear. Number 2, our graph looks like a line going like this. And unlike my picture, it looks sort of curvy. The one in the book is not curvy, so it is linear. All right, on number 3, it says determine whether the table represents a linear or non-linear function. So when it's in a table like this, one thing you can do is just compare the rate of change of the inputs and outputs. So on number 3, we have 1, 2, 3, and 4 for x, and our y values are -1, 2, 5, and 8. All right, so let's take a look at how these are changing. So if I go from 1 to 2 on my input, that's an increase of 1. If I go from 2 to 3, again, I've increased 1. 3 to 4, an increase of 1. If I look at my y values, my outputs, if I go from -1 and climb up to 2, I've gone up 3 places. If I go from 2 to 5, again, I've climbed up 3. 5 to 8, an increase of 3. And so, since the change in x and the change of y is constant, this is a linear relationship. Okay, it's a linear function. And we would say the rate of change is constant. Right? It's always, for every change in x, it's a change of 3 in y. So it's the rate of change is constant. All right, let's look at number 4. So again, in number 4, we have a table. And we have for x -1, 0, 1, and 2. And for y values, we have 0, -1, 0, and 3. All right, let's look how those are changing. All right, starting with the x values, if I go from -1 to 0, I've climbed up 1. 0 to 1, I've climbed up 1. And 1 to 2, I've climbed up 1. All right, so the input values are all increasing by 1. Let's look at the y values, or the outputs. If I go from 0 to -1, I've gone down 1. If I go from -1 to 0, I've gone up 1. If I go from 0 to 3, I've climbed up 3. Since these are not constant, since these are all different, right, our x values are, this function is nonlinear. And that says linear there. And again, this is because the rate of change I don't know why it doesn't want to write today. The rate of change is not constant. And if you can't read these very well, I do have the notes posted online, and you can look at those, the hard copies of the notes, and read better than this. This doesn't want to come out very nicely tonight. All right. Now we're on number 5. It says, is y equals 3 minus 2x linear or nonlinear? So in your notes today, you saw that any linear function is in the form y equals mx plus b. So the question is, can I rearrange this and make it look like a linear function? So I'm going to change colors here. So I've got my y, that's okay. But now I need this term with some number times x to come first. Well, it's right here. So I'm going to make this -2x. And then plus b, and that's a b by the way, or plus b in this case would be plus 3. So since I can write it in a form that looks like y equals some number m times x plus b, it is linear. All right, number 7 is asking us to find the domain and tell whether it's discrete or continuous. So from the notes today, you should notice that discrete data is a set of just points. So this example here would be discrete. Continuous is going to look like a solid line because the domain includes all these numbers in here, right? And there are infinitely many numbers between those 2 points. The domain here only considers these x values. And we have discrete data in real life all the time. Like if you're trying to figure out how many students can fit on a bus, that has to be a whole number, right? We can't have some like 2.5 children or 1 3/4 children. So that'd be a case of discrete data where it has to be whole numbers. Continuous data is just, it can be any number in this range. So I'm going to first of all write that this one is continuous because there are infinitely many points on that line. And this one is discrete. There's just a few points in the data set. And this is all in today's vocabulary that you wrote down. All right, the next thing we're trying to identify is the domain. When you have a domain like this, where it's just a solid line with continuous data, this is one of those that we did last class, where we have to write our domain as a complex inequality. So we know that x is between some 2 numbers. So let's first of all look at the big N. So if I go all the way over here, this x coordinate that corresponds to this point right here, this is the point 5, 1. So 5 is the biggest value that x can be. If I look at this point here, and remember, I'm not concerned about the y value. So even though it's up here, I've only gone over 1 for x, and I've gone up 6. Right, so the smallest x value is this one. So our domain is any x value between 1 and 5, including 1 and 5. So like 3 is on there, 2, 2.5, 1 3/4, all of those are elements of the domain. All right, in this one, I'm just concerned about the x values of these points. So this first point is the point 1, 3. This next point is the point 2, 4. And this point is 3, 5. So our domain is just those 3 x coordinates, or those 3 inputs. So it's discrete. So our domain is 1, 2, and 3. All right, your assignment today is on page 117 in the book. You're to do problems 5 to 11, 27, 28, 58 to 61. Please be sure to write the assignment number on your paper. If you're doing this assignment remotely, be sure to take a picture of your finished work and submit it through Schoology. There are 2 ways to access this assignment. It wasn't linking when I recorded these, so the other way to get there is just to go to the course homepage. You'll see the daily agenda link is the first thing on that materials list. Click on that, go to today's date, and you'll be able to find the link to this assignment. Okay, good luck.